All right. So differentiation was propounded and invented by Sir Isaac Newton. Okay. Sir Isaac Newton is the father of physics. Exactly. So he brought about the whole concept of differentiation. And with the first principle of differentiation, he said that what differentiation is in the form of what f of x. Okay. It's in the form of f of x is equal to f of x plus what h, okay, bracket close, plus what, it is rather minus, exactly, minus f of what, x, exactly, all over what, h, uh, all over h. And this is noted as what the first principle of what, differentiation. So let me write over here. I write or denote it as the what first principle of what differentiation. This is the first principle of differentiation. Please, you have AI.
AI, yes.
Okay, so you can ask AI now on your phone,
Mm-hmm.
who discovered differentiation? And let's see the answer AI will give us. Okay, so this is the first principle of differentiation. This is the first principle of differentiation. Okay, and the first principle of differentiation is a form of what? F of x is equal to f of x plus h minus f of x all over what? H. All right, please, can you read to me what did you get?
Okay.
Yes, sir.
Okay. Differentiation. Let me first say the meaning. The meaning of differentiation
Okay.
is a fundamental concept in calculus.
Yes, sir.
It was developed independently by two mathematicians,
All right.
Sir Isaac Newton of England,
Yes, sir.
1643 to 1723, 27.
Okay.
And then the second is Gottfried Wilhelm
Okay.
Leibniz, Germany,
Okay.
1646 to
Okay.
1716.
Okay.
Yes.
Okay. Thank you very much. That was a very nice contribution to the class. Also, I want
Mm,
you to ask AI now again that uh,
mm.
what are the contribution of differentiation to building technology?
What are the,
Contribution of
okay,
differentiation to building technology. And let's see some of the feedbacks it's going to give us. Okay. Yes.
okay.
Mhm. So have you gotten the full concept of my question, please?
Yes, sir.
Okay. So kindly simplify that for me, please.
To building construction.
Yes. Contributions of differentiation to building construction. And let's listen to the answers we are going to get. Okay. Don't be surprised. You are going to get
Mm,
wonderful answers. And you also, that is when you know the importance of some of the course we are reading. Okay. And so one may
okay.
ask that, why are we reading differentiation? We came to learn building. You see, so one may be worried. But after you are also able to read this out, at least a listener will be able to understand some of the contribution and the importance of differentiation to the field of building technology and also building construction, not also just to that, the whole civil engineering department also.
Mm, okay.
Okay.
So it's here.
Yes, sir.
Differentiation in construction.
Okay.
In building construction, differentiation can refer to the process of creating unique features
Okay.
or design that set a structure apart from others.
Okay.
Some contributions of differentiation in building construction includes customization,
Okay.
aesthetic appeal,
Okay.
functional efficiency,
Okay.
competitive advantage.
Okay.
Mm,
Oh, that's just nice. That means that at the end of the day, after learning differentiation, our mind is going to
mm,
develop in such a way that
mm,
all what you mentioned, we are going to be adapted to such things so that in real life, when we
mm,
encounter such challenges, life can be much more easier. Okay. So this some of these mathematical
mm,
concepts we learn, it have impact on us. Okay. Uh-huh. Learning some of these mathematical concepts is a way of just training your brain, okay, to be able to handle technical problems.
mm,
All right. So, please,
mm.
is that all? Can you read the rest to us?
Okay. Is this what you were thinking or you were referring to? Okay. So I should go into detail.
Yes, please.
The
Yes, please.
okay. Customization.
Okay.
Differentiation allows architects and builders to create tailored design that meet specific clients' needs,
Okay.
enhancing user experience and satisfaction.
Okay.
Aesthetic appeal. Unique features and designs can make a building stand out, increasing its visual appeal and potentially its value.
Okay.
Now, functionality efficiency. Differentiation can lead to innovative solutions that improve a building's functionality, energy efficiency, or sustainability.
Thank you.
Now, competitive advantage. Buildings with distinctive features can attract more attention, tenants or buyers, giving them a market edge. Mm,
Okay.
so please.
Okay. Thank you very much. Thank you very much. May God
Mm,
richly bless you for your contribution. So we want to simplify this problem, okay, from the first
okay,
what principle. Okay. So this is differentiation. We are going to start differentiation. And we are going to start from the first principle. Okay. So the first principle, we said that you just told me that it was discovered by two people, Sir Isaac Newton and also one person. But I can tell you that the key factor is Sir Isaac Newton. And basically, this
yeah,
was the key concept he came about with solving differentiation. That is, it was obtained from a graph, and this is a slope of a graph, okay, and it is in the form of it is in the form of y2 minus y1 all over x2 minus x1. But from the graph or from the curve which we took, this is what we obtain. It is an experiment, okay. One day I'll show you that. After the experiment, we obtain this, and this is a formula to solve whenever you see a question that tells you to solve a differential or find a differential or the derivative of a function from the first principle. This is the formula you're going to use. Okay, exactly. So an example is this question. The question says that find from first principle the derivative of the curve. Okay, y is equal to what? X exponent 2. Okay, exactly.
excellent.
So let's see how we can be able to solve this problem from the what first principle I just spoke about. So this is a what a solution in short. Okay, what did we say? First of all, I have to repeat my question for what 1 mark. So y is equal to x exponent 2. So they say I should solve from the first principle. Okay, but we just learned that from the first principle, our what dy dx, okay,
Mm,
our dy dx is in the form of what f of what x plus what h, okay,
yeah,
all over what h, when we come to the numerator, minus what f of what x, exactly. When you have this like this, Now you can break your solutions into sections and see how you can be able to make life much more easier. Okay, let's quickly proceed. Okay, so this is the formula. Okay, first of all, you put the formula down, and you see this formula over here. This over here is just the same as what I've written over here. Okay, so when you see this, don't get confused. And take note that your dy dx, your
Mm.
dy, your dy dx is the same as what y hot prime. Okay, and also f hot prime. Thank you very much. So in place of this, you can use any of those symbols you see over there. So how do we express this in this form? So you can see that our function is in the form of what? The first one is what? F of what? X plus what?
Plus
H.
H.
Okay. And the second one is in the form of, it's just in the form of F of what? X for the numerator. Okay. For the numerator. Let me
Okay.
say for the numerator. So this is just for the numerator. Okay, so I just pick the numerator. From here, you just pick the numerator. Okay, when I pick the numerator, this is what I get. Okay, so at the end of the day, what am I going to get? The numerator is just the top one. Okay, so what
Mm.
am I going to get? It implies that it is just this one that I just picked. I hope you can see what I'm talking about.
Yes, sir.
Just this one. So those are the one I have
Mm.
outlined over here. So how to solve
Oh,
this is I want to express this function I have written over here as that. So the first one is equal to what? The x squared. Anywhere you see x, you're going to put what? X plus h over there. So the function is just one. It's just x squared. So I'm just going to write what? S what? Plus h or what? Squared. Okay.
oh,
And then in place of the f of x, what am I going to write over there? I'm just going to write what? X or what? Squared. Can you see?
oh.
Uh-huh.
Yes, sir.
So I'm going to rewrite this whole dy dx again, and then I'm going to represent whatever you see over there. The denominator is still the same thing. Okay, the denominator is still the same thing. If you like better still, I can still write it for you to see. So the denominator h is still what? H. You see it. You see it. So whatever
Oh,
is in the green pen is what I have just taken time to just break down over here for you. Okay. In our next step that we are going to be going to talk about. Okay. Yes. So over here, what do we do next? Let me quickly clean this and then let's move on. So I'm quickly going to use a different color pen. And finally, you realize that this is going to become what? Dy dx. Dy dx, which is equal to, always the denominator is going to be the same thing. So it is still h. Okay.
oh,
And the numerator, what was the numerator? They say that what? It's our h of x minus f of x. You see, this is it.
oh,
So in place of the f of x, what are we going to put over there? We are going to put x plus h all squared.
oh,
And that is going to become what? X, or let me come and write it over here for you to see. The first one is going to be f into bracket what? X plus h all squared. X
oh,
plus h all squared.
yeah.
You see it. And the other one is going to become what? Now the sign over here is a major sign. We have to take note of that sign. Okay, this negative sign means that it affects everything in the bracket. Yes.
Oh,
And the other one is f of x. But the f of x is also what? Squared. You saw that the x was
oh,
squared. Exactly.
oh,
Exactly as the x was squared. So as it is over here. That is what I've written
Yeah.
over there. You can, I hope you
Mm-hmm.
can see what I'm talking about, please.
Yes, sir. Yes, sir.
Okay. So from here, it means that we have to further go on to simplify. So what you are seeing over here, I'm going to rewrite that for you to see. Over here, you see that from in the physics world, you realize that F can cancel F, right?
Yes, sir.
F, this F can cancel this F straightforward. You see,
Mm-hmm.
uh, negative F plus positive F will cancel each other. And at the end of the day, you realize that we are going to be left with what? We are going to be left with our dy dx, our dy dx being equal to just x plus h,
Yes.
you see, all squared
Mm.
minus, let me still use the red pen so that you get a better understanding. Minus, let me say x. So it's going to affect it and it's just going to become what? X squared. Okay, yes. So to further not confuse you, let me still maintain the same color pen so that precision can be enhanced. So this is still x squared, okay, all over h. You realize that the h is still the same, okay, yes. So from wherever we started to wherever we have gotten to, I want you to just take a look at something, okay. Where did we start from? Um, I think we started from here, right? We started from here, right? Hello? Hello? All right.
Yes, sir. I'm listening, sir.
So I think we started from this side, right? From the first
Yes.
principle.
This way.
Yes, find from the first principle the derivative of this. Okay, and first of all, we came
This
to,
number two.
yes, we came to repeat the question for 1 mark, and then we put the formula down. That is differentiation from first principle. So I told you that your dy dx is the same as what? Y prime, which is equal to what? F prime is the same thing. And then from here,
Mm.
our f of x, which is equal to our f of x plus h, we have expressed that our f of x, you consider we have expressed it. So the denominator is still the same thing. So the functions which is in the formula is what I have expressed over here in terms of the question that is being given to us to solve. Okay, good. So at this point we have gotten to, do you have any question to ask before we proceed? Hello?
Mm.
Do you,
Hello.
do you have any question to ask before we proceed?
No, it's clear.
Okay, so let's continue. Okay, so from here we have to
Okay.
just simplify this. Okay, and this is equal to what?
Mm.
Our dy dx. This is equal to dy dx.
Mm.
This is equivalent to dy dx, which is equal to what? What you are seeing over there in the on the numerator, it is,
Mm.
it means that what, two brackets. So it means x plus h, okay, in one bracket, and also another what, x
Yes.
plus h. I hope
Mm.
you have seen this concept before, please. Hello,
Yes, sir.
please, have you met this concept in maths before?
No, please.
This concept, have you met this concept before? Hello,
Yes, sir. Yes, sir. I've met it before.
okay. So this is how it's going to become. Okay.
Mm.
Then after here, I can still maintain the initials. Okay. This was negative what? X exponent what? 2. Let me maintain the same color pen to enhance precision. So this is x squared. Okay. So finally, you realize that to simplify this bracket, these two brackets are multiplying each other. Dot means multiplication. Okay, so we have to simplify them. So how is the simplification going to become? You realize that our dy dx. Please, do you have any question to ask so far before we proceed? All right,
Let's scroll down small.
all right, okay. You
Yeah.
have, I hope you don't have any question to ask, or you have a question to ask before we proceed.
Let, uh,
Don't worry, very soon I'm going to give you the videos. You're going to still have access to all of this. Okay, so
okay,
don't be in a hurry to write. Okay, just follow the
okay,
videos and life is going to be much more easier.
okay,
Okay, uh, when you
okay.
have the video, you can pause and go back, reverse, and have time to just write everything as it is. Okay, don't
Yes,
worry,
okay.
let's just move on. So how to simplify these two brackets because they are multiplying each other, and because it's a bracket of two squares, that is why it has been written like this. This over here you are seeing is the same as what I have expressed over here. Okay,
Oh, okay.
so to simplify this, it means that you have to multiply these two brackets. Okay, so to simplify this, it means you have to repeat one bracket twice and you use the other one to multiply. So I choose to repeat this bracket, this one rather, and
Okay,
repeat this one twice, and that is going to become
okay.
what, x plus h.
Mm,
Okay, I close bracket and also I repeat it again, x plus what, h, exactly. Then what am I going to do to the other one? The other one, I'm going to use a green pen to denote it. This one, I'm going to use green pen. So I'm going to, the other one is what, x. You see, so I'm just going to put x over here, and the friend is
mm,
what, plus h. So I'm going to put plus what, h over here. So plus
mm,
h, exactly as I've just written it. Okay, now I can cover it neatly. I can cover it neatly as it was. I can cover it neatly as it was. So finally, I can say that our answer is going to be what? This is going to affect that and it's going to become what? Minus what? X squared. Okay. So to simplify what you are seeing over here, we have to use what you are seeing to what? Multiply whatever is in the bracket. So our dy dx is finally going to become our dy dx. Let's use whatever you are seeing outside the bracket to multiply what's in the bracket. So x times x is going to give you what? X squared, right? Plus
mm.
what? XH. So
Yeah,
we're
SH.
going to get XH. Good. The other one too is going to become what? X times H is going to give you what? Plus what? XH. Okay. And then H times H is going to give you what? H squared. In indices, when the bases are the same and they are multiplying, you add the exponent. So because H times H and H are the same and they are multiplying, there is one over here, there is one over here. So you add it. So it's at the end of it, it's going to become what? H exponent what? 2. Good. So I'm done multiplying the bracket of 2 squares. So I can still use my what? Black pen to cover it for you to see. Okay. Yes. Then minus what? X exponent what? 2. Please, do you have a problem with me changing the color of the marker? All right. So from here, our dy dx, our dy dx is finally going to become what? Whatever you are seeing up there is the same as what? All over h. Now this is going to be all over h. This one is also going to be all over h. Exactly as you are seeing. Exactly. So let me put the h over here. And whatever you are seeing at the top over here is the same as what, let's say x squared plus what, xh, okay, plus what, xh again, plus h squared.
H.
I hope you can hear me, please.
Yes, please. I can hear you.
Minus what, x
X square.
squared. So at the end of the day, what can you see? You realize that s squared can cancel s squared, right?
Yeah.
This s squared is going to cancel this what, s squared, because
Oh.
it's like you are having this one, x minus x is what? X squared minus x squared. When you group like them, x squared minus x squared is going to give you what? 0. So they can cancel
Oh.
each other out. When they cancel each other out, what are you going to be left with? Let me write what they are going to be left with a different color pen for you to see what. So your answer is going to be
Oh.
left with what? dy dx. dy dx, which is equal to what? Always the denominator is still the same, all over h, okay?
Yeah.
You're going to be left with what? xh plus what? Let's say x
SH.
cubed plus what?
H square.
Well, thank you. So over here, what can you see? You realize that this one over here is having a coefficient of 1. Okay.
Oh.
This guy over here is having a coefficient of what? 1. And this guy over here is having a coefficient of 1. Even this guy is having a coefficient of 1, but we don't write. Even this guy is also having a coefficient of 1. But in maths, we don't write it. I hope you also know.
Oh.
So from that principle, since these two people are the same, 1 plus 1 is what? 2. So I can write 2 and maintain xh. You see that?
Oh.
So whatever you are seeing over there, let me change a different color pen because you are going to be seeing a different thing again. And that is going to become what? dy dx, dy dx, which is equal to what? Let's say 2 what? xh, 2xh plus what? H squared. I hope you can see what I've written, please.
Yes, sir.
So from here, what do we have now? You realize that we have 2xh plus h squared from whatever we have over here. It means that these two people, what did I do to them? These two people, because they are the same
Oh.
people, I just write 2 over here and maintain both of them. Can you see what I've just done over here? This is what I've
Mhm.
done.
Okay.
Instead of writing both of
Okay.
them, I just
Mhm.
write 2
Okay.
and maintain the xh.
Okay.
It's the same as that what you are seeing over there. So from here, I want to now group like terms. Okay, because we said that dy dx, in actual fact, dy the x of x squared is just 2x. Okay, so but from the first principle, this is what the inventor adapted to solving such a problem. So that is why we are adopting to that. So from the first principle, he brought about all these concepts. In 10 minutes time, the link is
Mm.
going to go off. Maybe we have to just um, re-click the link and be able to join again. All right. So this is what we are going to get at the end of the day. We're going to get the y dx is equal to what? Just 2x h. Okay. I want you to now see it well again. So I want to repeat it again before I even proceed. Okay. All over what? H. So now let me simplify for you. And our dy what? Dx also again is equal to what? Dy dx is equal to, now to simplify whatever you are seeing at the top over here. I want what? 2x to stand alone. So what can I do for 2x to stand alone? Hello?
Yes, sir.
Because I want 2x to stand alone, I have to find a way to substitute the h out. Okay. So to
Mm.
substitute the h out, it means that I have to develop a plan B. And that is when I bring the h out like this, I'm going to have what? Just 2x, okay, plus what? 1h in the what? Bracket.
Mm.
When you multiply whatever I'm having over here, you will get whatever is in the bracket over at the top again. Okay. Whatever I'm having at over here, when you multiply the numerator, you still get whatever is at the top over here again. Okay. When you multiply it back again, you still get this. That is all I'm trying to insinuate. Okay. So from here, it means that h can cancel h. From
Mm.
here, it implies that h can cancel h. But because I don't want to confuse you, let me still repeat it again before I let h cancel what? H. Let me still repeat it again before I let what? H cancel H. So this is how this is going to look like. You see? So at the end of the day, we can say that what? H is going to cancel H. This H is going to cancel this H. So what are we going to be left with? We're just going to be left with what? The y, the x. Okay? We're going to be left with our dy, the x is equal to what?
2
2x plus what?
x
Plus h.
plus h.
Yes. When we get to this point, it means that we have to take limit of what? X is equal to what? 0. Okay.
Mm.
In the first principle, that is the rule. When you get to this stage, when you take limit of h is equal to 0, it means that you are going to be left with just 2x. Okay. Yes, I will show you just a trick now. So at the end of the day, we are going to take limit of what? H is equal to 0 so that we can be left with just 2x alone because we want to be left with 2x alone. So at the end of the day, our dy dx, what is it going to become? We are going to take limit of that and limit as h approaches what? 0 is equal to what? I think we just learned limit. So you now know what limit as h approaches 0 is going to be. So limit as h approaches 0, anywhere you see h, you are going to put 0 over there. And limit as h approaches 0 is what? Let's further simplify it. You realize that
Do so.
our limit as h approaches 0, okay, is simply going to be equal to what? Let's say 2x, and anywhere you see h, you put what? 0 over there. So finally, you see that your final answer is going to be equal to what? Your final answer is just going to be equal to what? 2x. Your final answer is just going to be equal to what? 2x. All right. Please, do you have any question to ask before we proceed? Please, do you have any question to ask before we proceed? Hello?
Yeah. Hello.
Yes, sir. Please, do you have any question to ask before we proceed? Please, do you have
Yeah.
any question to
It's
ask?
like uh we have gone back to the first example the first topic that we treated.
Oh, no, I'm not. Okay, let me just show you a single slide for you to see. This is a single
Okay.
page. Can you see the page now? Can you see the page? Can you see my page now? This is the example we started with differentiation. Can you see the topic? This is calculus.
Yes.
We are treating calculus. So limit is part of
Mm.
calculus. Okay. So after treating limits of function, the next topic is differentiation. Okay. So that is why we are taking it step by step. So after you are done with limits of function, you come and treat differentiation from first principle. So now when I'm taking limits of h is equal to 0, you knew how the whole concept came about, right?
Yes, sir.
Okay. So this is differentiation, and I told you that this is the formula we are going to always apply to be able to solve
Yeah.
our differential equations, okay? And this is the formula you are seeing over here. This is the formula you are seeing over here. After we saw the formula and we took an example, they said that find from first principle the derivative of the curve y is equal to x squared. Okay, in our solution, what did we see? We say we still repeat the question and y is equal to x squared. Good. And I told that dy dx is equal to y prime, which is the same as what? F prime. So you come and write the formula for what? An additional mark. When you write the formula, they will still give you 1 mark. So in all, you have 2 marks already. You see. So this first one, f of x plus h, I express this in terms of the question. The question they have given us is what? X squared. Okay, when I express this in terms of that, what did I get? I had x plus h into brackets all squared. Okay, I told you that anywhere you see x, you put what? X plus h over there. Good. And the second one, which is what? F of x. When I express, what did I get? I had what? Just x squared. Exactly. So from that concept, the denominator h is still equal to what? H. The denominator h is still equal to h. And that is why you are seeing what? H over here. From the same formula we saw, I still what? Repeated the same thing. Okay, good. From the same formula you saw, I still repeated. I hope you can see where I am, please.
Yes, please.
Yes, so from the same formula you saw over here, I still came to repeat the same formula over here, dy dx. And in terms of f of x plus h, I put what? X plus h squared over here and f of x squared 2 over here, as you are seeing, all over h. After that, I simplify what is in the hot bracket over here, all squared. And that is what we have over here in this next step, the one I just circled. I hope you can see exactly.
Yes, sir.
So from here, you realize that after expanding the brackets, we had what? After expanding, we came to expand it over here. And I told you that you repeat one bracket twice and use the other one to multiply it. So after doing the multiplication, we came to get what? X squared plus xh plus h squared minus x squared. Okay, all over h. At the end of the day, x squared is going to cancel x squared. And you're going to be left with what? Xh plus xh plus h squared all over what? H. I told you that this is the same as this because this has a coefficient of 1, this has a coefficient of 1, so it's going to give you 2 plus h squared. At the end of the day, when you substitute, at the end of the day, we came to do the substitution over here. Okay, so when you substitute the 2 out, what are you going to get? When you substitute the h out, you're going to be left with just this. Okay, when you substitute the h out, you're going to be left with 2x plus h. That is what we did over here. Now we are left with 2x plus h. When we take limit as h approaches 0, we are just left with what? 2x. Okay, so the zoom is going to cut any moment from now. We have to just take another 30 minutes to solve a different